Alright, what's up everybody? It's me again with another contraption. And here it is. Well, you might ask yourself, what is it?
What is it?
Thank you, honey. That's my wife. My lovely wife, whose birthday was yesterday. She's a redhead born on St. Patrick's Day. Happy birthday. But it is this. It is a computer power supply. With this cut off. This fan, the fan taken out, putting on the outside, and turned into this with binding posts. Well, Jason, why do you need a computer power supply when you have a perfectly good one over there? Well, I'm glad you asked. What this is a lab bench power supply. I guess that's what it's called. I don't know. But basically, if I'm building circuits and I need a power supply, as opposed to having to go find a 9-volt battery or a 12-volt battery if something runs on 12-volt, or a 15-volt power supply or wall wart or anything and hack into that and make my power supply, I can use this. Each one of these posts right here, and I don't know if you can see it, I'll try to show it to you, is 12 volts, negative 12, 5 volts, 3.3 volts, and ground. And so having this negative 12 means I can make, when I put the ground and the positive in here, I can have 24 volts. Same way here, if I put the ground here and the positive here, I can have 17 volts or 15.3 volts. Also, I can have just 12 volts if I put positive here, ground here, just 5 volts if I put the positive here, ground here. You get the idea. Also, if I wanted 9 volts, I would do the negative here and the positive here to get 9 volts. See? See how the math works out? It's pretty neat. So I'm going to turn it on so you can see it working. The light's on. The fan's running. Trust me, it is. You might be able to hear it. I don't know if you can see it, but it's running. Now the fan has to be on there because there has to be some type of load to make this power supply work. There has to be some draw of current in order for this power supply to turn on. So I either had to put a 10 ohm resistor, load resistor on here, or just use the fan. So I chose to use the fan because it looks cooler and it keeps it cool. So here we go. I'm going to test it out. Oh, also another feature is if I want to test to see if an LED works, in order to use a 9-volt battery on a breadboard, you have to put a resistor in here, because if you plug 9 volts into this, it'll blow up. Well, not blow up, but it'll blow out. It won't work anymore. So this having 3.3 volts, which is perfect to run an LED, all I have to do is stick it in there. If I can get it to work. See? And the LED works. See? Boom, doesn't work. Now it's on. See? But here we go. I'm going to show you the voltage readings. So I plugged my common or ground into here and plug this one into here. I don't know if you can see that. It's reading 12.3 volts. Whoa, you can't see that. It's reading 12.3 volts. If I put it in here, negative 11, almost 12 volts. If I put it into here, 5, 3.3. This is where the coolness comes in. One here, one here. It's messed up because I have it on maximum 20 volts. There we go. 24 volts. If I put it in here, 16 volts. It's supposed to be 17 because it's negative 12 and 5. Now here's the 15 volts. Now if I want 9 volts, I do the negative into the 12 volts, and I get 9 volts. And if I put the positive into 3.3, and so there you go. That's what I did. If you want to build one of these, you have ton of these laying around like I do. You can go Google ATX power supplies into bench test power supplies, and it'll give you step by step. It didn't take me too long to do it, but it is a pain. I got these binding posts from Teda Electronics, which is a great website if you need electronic components, because these were, I think, $1 a piece, and if you go to Radio Shack, they're like $1 for 2. And also got the LED there from Teda, and it was cheap. I forgot, but there you go. That's my lab bench power supply. There we go.